Okay guys, this graph is a little bit harder, actually a lot harder. We have a fourth degree, and the first thing I tried to do was find the roots, and it doesn't factor by grouping, so I went P over Q, tried 1 and -1, neither work. So if there's no rational roots, so they're going to be irrational, and the only way to find them would be on a calculator. So I did find a 0 at -0.6. So if you want to graph that on the calculator, you can see what the graph should look like. But sort of ridiculous to use a calculator to see what it should look like and then do it by hand. But anyway, it works. So no rational roots. It does, though, have a y-intercept. So that would be with number, I guess that's still part of number 1, find any intercepts. So I know I have a point at 0, 1. Then I take the first derivative, trying to find places where it's increasing and decreasing, and I get this factors to 0, 1/2, and x equals -2. So then here's me figuring out if I have the x values, what are the y values? So I have minimums at -2, -7, and 1/2, 13/16, and a maximum at 0, 1. And I know that this end behavior should look like this, right? It's a fourth degree, so both ends at the end should point up. So that helps me too. All right, so I know I have that, and I did my little sign chart. That's how I could tell minimum. This was a cubic function, positive, so it went through 1/2 and 0 and -2. So here's my end behavior. So at negative, positive, negative, positive. So this would be a minimum. This would be a maximum at 0, and there'd be a minimum at 1/2. So that's where that came from. So I found my mins and maxes using calculus, first derivative. Now let's find points of inflection and concavity by taking the second derivative. And I get this nice thing that I use the quadratic formula on, -3 plus or minus square root of 21/6, which is -3 plus is 0.26 and -3 minus is -1.3. So using end behavior, I see that it's positive, negative, positive. Negative end behavior of this function right here. I could have substituted in y with the calculator, but I didn't, so the y values aren't so good for the points of inflection. They're just approximate. But it did change, so there's a point of inflection right here at -1.3 and right here at 0.26. And it's concave up before a -0.26 and concave down between that and -1.3, and then goes back up to concave up. So how do we graph this? I want you to pay really close attention to this stuff right here, the blue and the red. What we do is we take all our critical points and our points of inflection, and we do dotted lines through them. And then we use our 2 sign charts and we do a double sign chart. So before 2, it was, if you look at the first sign chart, it was negative. And then between 2 and 1/2, it went 2 to 0, it went positive. So I have a red positive here, and then it went positive again between between those two, and then all the way to 1/2 to 0. So then it changed between 0 and 1/2 to be negative, and then from 1/2 on it changed to positive. So those are my red positive negatives. My blue ones are the second derivative, so I put those on the sign chart the same way. And now you see in this first space from here to here, it has to be decreasing concave up. So I know that, and let me get the blue marker again. This is decreasing and concave up, and I found out that minimum was at -7. So I do have a good point right here at -7. Between -2 and -1.3, it is increasing and concave up. So that means it has to continue. It is increasing and concave up. So no, this was supposed to be, let's see. yeah, increasing. And is this a concave up or concave down? Concave up, yeah, that's what I have. Okay, so from there to negative 1.3, it's increasing concave up. Then you can see from negative 1.3 to 0, it is increasing concave down. So that's where this line comes in, increasing concave down. Then from 0 to 0.26, it is decreasing concave down. So there's our max point, there's our y-intercept 0, 1. It's also a max at 0, 1. And then it goes down to here, and that's just that little hook right there, decreasing concave down. Then it changes to increasing concave up on the next section, increasing concave up, and then increasing and concave up. This one was decreasing concave up, and then this one was increasing. So when we did these at school, we did them on big graph paper on the boards. So it's kind of hard to see it on this, but it's good practice. Let's move on to example 3.